Welcome to online lectures by CA Studies. For more lectures online, please do visit castudies.lk.
Hi guys, let's now start with averages, a continuation of chapter 7. You must have learned this very well in detail, especially in your school in grade 8 onwards, in your O levels, A levels, definitely if you've done maths, this is nothing. But if you've done O levels, definitely you must have come across mean, mode, and median, which is easy. But let's therefore refresh our idea, our perspective to averages. Basically, this is like an introduction chapter because they are going to connect this with chapter 8, which is I think on dispersions, where they will look at measures of dispersions, and here they are going to just look at the averages, right? So it's going to be a bit relating to the next chapter. Okay, so what is an average? It is a representative figure that is used to give some impression of the size of all the items in the population. And there are three types: mean, mode, and median. What is a mean? The mean is the best average, right? So it is obtained by a formula which is for ungrouped data, right? Formula for ungrouped data, it is sum of values of the items divided by the number of items. Its symbol is represented by X bar, written like this. So in the exam they will not give you the word bar. You have to figure out the sign. So be familiar with the sign. Okay. So let's look at this example. The demand for a product on each of 20 days was as follows. So they have 20 items are here. If you count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So for each of the 20 days, they have given the demand for the product. So day 1, the demand is 3, day 2 it's 12, day 3 7, day 4 17, and so forth. Find the average demand for this product. That's how they're going to ask for in your question exam. What you do then? Put the sign mean sign, which is X bar, equals sum of the demand, which is 3 plus 12 plus 7 plus 17 plus 3 plus 14 plus 9. If you take the total, it will equal to 185. And that you divide by the number of days or the number of time, not the times, the days, like the, what do I say, the number of rows it represents, right? So, or the number of columns it represents, the number of cells it represents. Basically 1 2 3 4, there are, count the number of items. Okay, so the number of items here, the items are days, but the days represent the demand, and the total of all those demand is only we have to consider here, and they have considered 185 above. Then you will get your average number of units or demand per day. It is written, now they haven't written per day here, but you must remember, or you must understand that this is the demand for a day. In this example, demand on any one day is never actually 9.25. The arithmetic mean is merely an average representation of demand on each of the 20 days. Okay? Right. So, arithmetic mean of data in a frequency distribution. It is more likely in an assessment you will be asked to calculate arithmetic mean of a frequency distribution. Right? So, in the previous example, frequency distribution would be shown as follows. So you have demand of one item only one time. Then what you should do, so wait, so this demand into frequency column will be not given in the exam. They will only give daily demand and frequency. So let me show you how they created the table for daily demand and frequency. They selected the range of items. So the minimum amount of demand is 1 and maximum is I think 19, right? So anyway obviously it should be 1 to 90. And then they put random figures 1. They could have put 2 as well, but they didn't go to put 2 because I think 2 is not available. No? So it's pointless to put 2. But they've continued with 3, 4 and not 5 but 6, 7, 8 because they don't want to show a frequency of 0 here. That's the reason they put the numbers that exist but in ascending order. Okay. So in ascending order, they have represented the daily demand from one minimum value to maximum 19. And then they have counted the number of times we achieved the demand of 1, 3, 4, 6 and so forth. So demand of 1, see how many times we have received in this 20-day period. Only 1 time. Then demand of 3, how many times? 3 we have 1 3 over here and another 3 over here which is 2 times. Then you have 4. 4 how many times? Only 1. Let's consider another one. 9 how many times does it have? 9 has been achieved in one day and the second day as well. So basically 2 days, right? Eventually, as I said previously, total of the frequencies must be equal to the total number of items, which is how many items? 20 items. Why is that? Because items here are represented as days and so there are 20 days. So 20, cells are here or 20 items are here. Hence, this should be equal to 20. So that's the step 1. Then next step is multiplying your demand with the frequency. You multiply 1 by 1 and get your fx value. They've named daily demand as x, frequency as f, demand into frequency as therefore fx. 1 into 1, 1. 3 into 2, 6. Why is that? What is this representing? The sum of the demand, isn't it? As you see here, 185. The same thing by multiplying also we know by mathematical ways, multiplying and adding, in a particular way will give us an equal value. Hence, we arrived at the total summation at each. For this 10 daily demand, we have a frequency of 10 itself. But 8 daily demand, we have a demand into frequency of 8. Yeah, but 9, it's 80. Likewise, it's a demand into frequency. Basically, the summation. So, if they give this fx column, usually it is written as known as fx. So, if they give fx, so your x bar or mean will be equal to fx divided by summation of f. What is the summation of f? 20. What is the summation of fx? 185. Divide, you get your mean. Right? Now, when I said summation, I was saying no summation. For summation, there is a symbol in maths or stats. That is sigma. Sigma is a sum of set of values. So, I'm sure you must have come across in your O-level time. The mean, you write it as mean bar equals summation fx or sigma fx divided by sigma f or sigma fx divided by n. Okay, where n is the number of values recorded or the total number of items. Say n is equal to sigma f. Sigma f means 20, the total. Sigma means the total. Okay. So we've learned arithmetic mean in a frequency distribution. Now let's see how to calculate arithmetic mean in a grouped data. That means you have grouped into categories like this, groupings. Now the same table they have made it like this below as groups. Right. So now what you are supposed to do is, first of all, you should identify the midpoint of each of these groups. So, how you know the middle point is actually, so now the first class if you take, it is only greater than 0 and less than or equal to 5. That means not equal to 0 because it's just having only the greater than mark. It doesn't have the greater than or equal mark for next to 0. Right? This side. It's only the greater than. Since it is only greater than, it will consist of the numbers. This class consists of the numbers 1, 2, 3, 4, 5. Right? So in 1, 2, 3, 4, 5, obviously we know the middle value will be 3. Why is that? Because 2 will be behind, two numbers are behind 3 and equally two numbers are after 3. So a midpoint is a point where the numbers behind it, the number of items behind that number and the number of items after that number is the same. Okay, but now this is when your data is discrete. That means it is not continuous, right? Like you remember the one that we did with 700 to 799, and then the next one is 800 to 899. Such classes are discrete classes. So for such classes we can have midpoint of 3. But of course we learned that discrete classes can be considered as continuous classes as well. However, with a continuous variable, midpoints would have been 2.5 to 7.5, so forth, right? So once you decide your midpoint only, we will determine the mean. So 3 is the midpoint for this class. Now this class is greater than 5 and less than or equal to 10. That means it has the numbers only 6, 7, 8, 9, 10. 6, 7, 8, 9, 10. So if you take in your Excel 6, 7, 8, 9, 10. So two numbers this side, two numbers this side. Therefore 8 will be a midpoint, which is perfectly 8. 10 to 15, so this is only greater than 10 and not, this sign is only greater than 10. It doesn't say it is equal to 10. So, it is but equal to 50. It's up to 50. And this represents a continuous data because you see it is 0 to 5 and then from 5 to 10 and then from 10 to 50. The same last number is the first number in the next band, right? So that is what you need to basically for see just understand. Fine. So the next class 10 to 15. So it will have 11 to, even though it is 10 to 15, it doesn't equal to 10. So it will start from 11 and then continue 12, 13, 14, and of course it's equal to 15. So we will have 15 here. And then two numbers this way, two numbers this way. So equally there is a spread. That's why. So if there is only, let's say, one number this side and two number this side, then what will be the midpoint? Now altogether four numbers. What is the middle point? It should be 13.5, isn't it? So you could always, for the exam, you could view it, you could take what? The number line. You can draw the number line. That's the best way to identify your middle point, I would say. Because you have, so because of the number line, you will know this is 12. And then we have 12.5, like the ruler format. Take your ruler, right? And then check 12.5, this is 12.5, then 13, then 13.5, 14, 14.5. The ruler has all the numbers. It has from 14.1 to 1, 0.1, 0.2, 0.3, 4, 5, 6, 7, 8, 9, and then the whole number comes. That's how the ruler works. So in the rule, always to find the midpoint, use the ruler format. So you will have 13.5 if you take a ruler and see 12, 13, and then 13.5 will give you this side 1.5 units and this side 1.5 units, ultimately making 13.5 the midpoint. Yeah, so so basically likewise, so now in this case it is not 13.5 because it starts from 11, so it's 30. And then the frequency as given in the question itself 4862, same thing what is given, they have put it here and taken the total 20. Once taken the total, now in normal frequency, what they did was they multiplied the frequency by the demand, right? What they did was fx was multiplied the demand multiplied by the frequency. But in a grouped data, the midpoint multiplied by the frequency only we must be obtained, not the demand. Right? So midpoint multiplied by frequency is, as you could see, 12, 64, 13 into 6, 78, 18 into 2, 36, so forth, and they have taken the total. Now apply your mean formula, which is not changing at all under any circumstance. It is always sigma fx divided by sigma f. Now the sigma f here is the frequency, same as previously the frequency, the number of times. But the summation of values only changed. Previously under normal frequencies it was the summation of daily demand multiplied by frequency, but this time it is midpoint multiplied by frequency because this is a group. That's the reason. Remember that very well. This is a group, but before it was not a group. So you divide it and you get 9.5 units. So when you compare the grouped frequencies and the normal frequencies, the answers of the mean, previously we got 9.25 units here. Yeah, 9.25 units under frequency distribution, normal frequency distribution. In a format like this, no any groupings. But when you group and got the mean, it's differed. It increased to 9.5 average. So there's an error of 0.25. So they say, so as frequency become larger, the size of this approximating error, that means the 0.25 error becomes small. So for large data sets, the difference will be less between a, between a grouped data set and the same data set not grouped. Okay, so in such ways only it comes. Right, so now let's see arithmetic means of combined data. Now we had group data, now we have combined data. Suppose that a mean age of a group of 5 people is 27 and the mean age of another group of 8 people is 32. How would we find the mean age of the whole group of 13 people? Okay. So now they are saying, so we first of all write the formula for mean. Mean equals, since the sign is not available, I'm gonna write sigma itself, the word sigma fx divided by sigma f. Now we need to know how to calculate the sigma fx. So they just gave mean of 5 people is 27. That means they got the mean 27 for 5 people, means that should be the total frequency, right? Because this is f is the anyway the number of items and this is the summation of values of the items. So the number of items is the number of children. So or number of people. The number of people here is 5. Right? So you give 5 over here. And this is unknown, it will be x. Now comes the algebra. How you take 5 here? What you do is you multiply this side by 5 and multiply this side by 5. By now you must be very familiar with multiplying these, right? So 5 into 27 will give you 135. So the fx, x is now, sorry, x is equal to 135. That means sigma fx, this value is equal to 135. Then second group, 8 people and a mean of 32. So I am going to straight away, same formula you should apply, same method. So straightly I am going to take x2 for the second group is 8 multiplied by 32. The mean is 256. So this is group 1's item, this is group 2's item, which is 256. And here the number of people are 5 and here the number of people are 8. And they are asking the total net mean of 13 people. So to get the net mean, what you need to do is simply add these two totals and add these two totals. And then divide 391 by 13. That's how you get it. Okay. Now answer net or the new mean for all the 13 people is 30 years, 30.08 years. You must mention what is it, years or days or whatever. Right? Okay. So this is how you combine, you find means of combined data. So this is the total. So they found the mean of one set. This is the mean of the other set. We don't know how they multiplied. Did they multiply by the midpoint or they multiplied by the age itself? We don't know. But we know, however, that this is all, it is correctly obtained as it is given in the question. So, why we don't have to multiply or do anything again, right? Because these are the same category. Summation of value of items of group 1 plus summation of value of items of group 2. Same category, both are summations. That's why we can peacefully add it. Otherwise, we cannot add two separate things simply. The reason why we add it is because they are summations and they are of the same nature. That's the reason. And the denominators are also of the same nature. Both are people of the same class or whatever. So that's why we added an obviously, right? You can add it and then divide it each and you get your new average age for how many people? 13 people, right? Which is 30.08 years. Easy. Okay, so when we look at the advantages and disadvantages, advantages includes easiness, easily understood, it's a good representative of the whole data set, and it is supported by mathematical theory. Yeah, those are common benefits. But when it comes to disadvantages, well, it is not actual value because it's an average, right? Now, for averages cannot be applied in every scenario because if you take an average number of children in families, you might end up in an answer of a decimal answer 2.3 children. Now, can you have 2.3 children? Human beings, two and a half, two and a third? You can't have such numbers because human beings are in whole, right? So no family has exact 2.3 children, right? So that is it's not a good representation at such scenarios. Secondly, arithmetic means might be distorted by extremely high or low values. Because if you have values like 1, 2, 3, 4, 5, and to find the mean, well, it will come to reasonable value. But if you have 1, 2, 3, and then 25 and 100 is the next value. Then when you calculate the mean, a very big gap will be there. But if you actually see, only 1, 2, 3 is the lowest majority and only two figures were 25 and 100, very high values. Like so it's like this. So it's 1, 2, 3 and 25 and 100. So the mean will be the total of these. Sum total of these divide by the number of items. How many? 1, 2, 3, 4, 5. Sorry, 5. So you get 26.2. But because of but is it average 26.2? No, right? Because majority represented by only single digit numbers and only one was there near to 26.2 which is at 25. The rest is 100. So see, because of these two data that it drastically changed. Now in case if I take off this data and then divide by 3, then you see it's 2, average 2, of course, right? It's a good representation of the 3. That's what they say. So this is a grouped data example. So you have to find the midpoint of each in grouped data and get your frequency. That's what you basically have to do. That's what they've done here. So basically this is a continuous data. That's why they have used words. Okay. But even though it is continuous, you know that we should use signs like this. Always this side must be in this single manner and the other side must be greater than or equal to. Or the other way around. Your choice. So it depends. Now let's do this example. So here they are saying it's under 60. So that means how you should write this data. You should write as under 60 now, so the sign must be the other way because you have to assume the number is this side. Like you should assume maybe the unknown is x. X is less than 60, under 60 items. That's why they are not showing the x here. Simply no need to show. No, that's why they are showing the sign other side. So the sign other side, how many items? 3. Then 62 under 70. So now under 60, and then this is 62 under 70 now. So this should be greater than or equal to, since actually it should be the slash below the greater than sign, but since I am unable to do it here, I will use the equal sign, but there is no sign together like this. Please don't complement. But of course, yeah. So greater than or equal to 60, and less than 7. Now this range is 11. Next one, greater than or equal to 70, but less, because previously I didn't say equal to 70, no. So here I can say greater than or equal to 70, because previously also it is less than. So now this time greater than and also equal to 70. Equal to 70 but under 80. This is 60. Then 80 to 90. 50. The rest is over 110. So since it's not equal here, I'm going to say greater than or equal to 110. But in this case, now we have to remember that we should have a standard width, right? So let's see if there's a standard width here. There's a 10 gap. The gap is 10. Here also 10, 10, 10, 10. So that's fine. All 10. Here also probably it should be a gap in 10. Yeah. So since it should be a gap in 10, you remember that we now don't write something like this. First of all, we have to ensure the same gaps are there, and if so, if there is no end value, we have to create an end value of probably same set as above, which I'm going to add 10 to 110, then I'll get 120. So, and also here it is less than 60, and I'm going to minus 10 because the gap is obviously 10, and I'm going to get 52 less than 60, right? So that the gap is 10. So here and here I adjusted, I changed according to what we learned initially. If you go back, I told you all the steps that you have to adjust, where we learned about adjustment factor and multiply it into the frequency to get the histogram. The same theory that there was learned there, same thing. First of all, when setting, it applies only to continuous data. So that means data with such words. So if you see data with such words, then you first convert it like this, right? And then just put these figures as given in the question and take the total, right? Um, Okay, now we'll see. Now it's a group data. So step 1 is basically making continuous data grouped, right? Grouped with similar widths, that means class widths, and changing and including end values for all classes as part of like in histogram. Refer histogram section for this. Okay. So now we made it a grouped data. Now we know in group data to find the mean, what we should first of all do, we should get the midpoint. What is the midpoint between 50 and 60? If you take a number line, it will be 50, then 55, then 60, right? Then the midpoint is 55. So select. Then here it will be 65. And here 75, 85, 95, 105, and here 115. Now this is midpoint, we call it X, and the frequency we call it F. No, isn't it? That's the way we do it. Then the Fx value will be frequency multiplied by midpoint. Get the total, and now get the summation or sigma Fx. So this is equal to sigma Fx. And then what is sigma F? Is 69 over here. Now therefore what's the mean? Mean formula, sigma Fx divided by sigma F. Is equal to 5835 divided by 69. Is equal to average 84. Yes, it is. So basically, yeah, so if you read the answer itself, you can the same explanation you get. So this is about the wages earned by 69 operators. Okay. So the average salary of an operator is 84 pounds, 84 rupees. Okay. That's the so you must say, you can't just simply write 84. Now in the question they will give something 84 whatever. 84 people they might give, or 84 something. So you must say 84 rupees. Okay. Yeah, very easy. Moving on, let's move on to mode. Now mode is the frequently occurring value. That means out of the frequencies, we are going to select the highest frequency. If you look at a particular example, this one. So, demand and the number of days that demand we received same demand. So, we received on 3 days, we received demand 6 units. So, day 1 also we received 6 units, day 2 also we received 6 units, day 3 also we received 6 units. And therefore, for 3 days we received 6 units. And for 6 days we received 7 units. 1 day only we received 8 units. Now what mode says is that see how the highest number of days that you received a particular demand. So in this, if you compare the number of days, the highest number of days is 6, isn't it? Because for 6 days we have continuously received 7 units demand, or as compared to 3 days and 1 day. So 6 times we have received highest number of times, right? We have received a demand of 7. So the mode is not 6. We don't say in days. We say it in demand. No? Because we want to know what is the average demand, not the average days. That's why we write there for the mode is 7 units, because it is the value which occurs most frequently, which is 6 times. But if you look at a grouped frequency distribution from a histogram perspective, so you have 0 to 10, 10 to 20, a continuous data with fixed intervals, because the gap is 10 here, here also the gap is 10, here also the gap is 10, 10. The frequency 0, 50, 150 and 100. The model class, the one with the highest frequency, is 20 to 30 because it has 150 frequency. It is the highest when compared to the rest. But how can we find a single value to represent the mode? Now in grouped data, we have grouped it now between 20 to 30. But how can we identify the exact value that will give us that will represent the highest frequency? For this, you first of all have to draw a histogram for continuous data. Now, continuous data histograms, as you would refer back, they are all connected. They don't have gaps between bar charts or the bars, right? So, if once you draw your histogram, basically 0 to 10 you have nothing, so that's why there is no bar here. But 10 to 20 there's 50 units, which is they have marked the upper limit as 50. 20 to 30 upper limit 150. So this is basically it's presented in a simple bar chart format, but since it's continuous, the bars don't have gaps. So the model class, the rule is in finding, once you draw the histogram, they say model class is always the class with the tallest bar. What is the tallest bar? 20 to 30. That you don't have to draw a bar to see that. You could actually pick it from here, but they are now trying to link it. But this may not be the class with the highest frequency if the classes do not all have the same width. So basically, since that means they are saying the width is the same here, so it's okay. But if the width is not the same, let's say 20 to 30, the gap is 10, and the next band's gap is 20. Then we can't say that 20 to 30 is the mode because the gaps between each of the class bands are different. Right. So, we can estimate the mode graphically as follows. Join with a straight line the top left hand corner, which is this way, of the bar for the model class and the top left hand corner of the next bar to the right. So, the left hand corner. So, it's interesting. It's some mathematical perspective. It's just like a drawing, okay? So, what you do here is look at my cursor, okay? So, now you're now only looking at the class model class. I mean the class with the mode or the model class 20 to 30 because it has the highest frequency. Now draw a cross line from the start of at the cursor point I am showing here towards the point that joins with the next bar. Now here only it joins the next bar, right? So up to there draw a line. Then from the other side, look at the cursor where I am pointing. From there onwards, draw a line connecting to the point which connects with the other bar. Then the intersection of those two lines is the mode value. Interesting, isn't it? So basically it is more useful in a graph paper. That is where, because it's with a number line with equal squares. So sometimes in the exam they might give a histogram with a graph paper requiring you to find the mode value. Then first step is you have to find what is the model class, and the second step is for you to first of all draw these two lines and find the intersection point, which is 26.7. If you have a graph paper, you can easily track it. Well, they say you cannot draw a histogram in a computer-based assessment. So questions may ask you to interpret a diagram. So You're free. You don't have to draw the histogram. But obviously they will ask you what is the mode? Is it 26.7 or 40 or whatever? So first you should know, okay, how we calculate mode in what this situation in a grouped frequency distribution, right? And then mm, decide, make sure that the gap between these classes is the same. If it is different, you should make it the same in a way, following the steps using the adjustment factor. You remember when drawing histograms we use the adjustment factor multiply by the frequency. That value only will be the height of the bar, right? Not the frequency. In this case, it's the frequency because the gap in all the bands or all the classes is the same because it's a gap of 10 in each item. But previously we saw it is not unequal class intervals. If you go back to your histogram section where we learned about unequal class intervals, you will see that the gap is not the same, and because of that we take an adjustment factor, which is we first of all select the most common gap, which can be an average gap or the most common gap that will satisfy all situations. Now there it is a bit fishy because one person might select one gap, another person might select another gap. But in the exam they will give in a way it is very visible, right? Or very obvious. Once you select that standard gap, that you divide by the current gap, get your adjustment factor, and multiply it by the respective frequency, then you will get the height of the bar which you should use to draw your histogram. And the y-axis of the histogram will represent the frequency density. Okay, so with that way only you should draw the histogram and then mark. But now in the exam they will not ask to draw, obvious, but you should know how it was drawn in the exam for you to give a correct answer. But even though whatever method they arrived at drawing the histogram, the x-axis only will determine what we are looking for, as in the demand or the whatever it is. So you could simply mark the mode by looking at the x-axis, because y-axis only will in that case will give the frequency density in that unequal class interval case. But in the so this side will be frequency density, but this side will be the values or the whoever the group, this set. X-axis will always be the class interval. So there is no need to worry. You could straight away, even though it's an unequal class interval or normal class interval, no problem. You could straight away get the mode in this line method. What are the advantages again? Easy to find, not influenced by extreme values because we select the highest frequency and get a match. Can be used for data which are not even numerical. Can because it's because we interpret it from a diagram, and it can be the value of an actual item in the distribution. But the disadvantages, it takes no account of a high proportion of the data, which could be a problem. It does not take every value into account. There can be two or more modes, we can't say. And sometimes there could be some instabilities. So those things, just remember the keywords so that in the MCQ they will ask the keywords, right? So once you remember the keywords, it will be easy for you to tick the right answer. Next, the last one, I guess, it's median. So median is another type of average we use to find averages of information and data. Median is also known as the middle value. Okay, So the middle value is found by the formula n plus 1 to the power, divided by 2. Let's do some examples. So the median of the following 9 values. So there are 1, 2, 3, 4, 5, 6, 7, 8, 9 items. How you found the median? First step in finding the median, write down. Arrange the numbers in ascending order. You know what is ascending order? Small to big. That's why in this question they have, so it starts from 8, but they have first of all rearranged it to 3. Then the next large number is 6. And there is another 6 also. So they have put that also here. And there's another, then 8 is the next large number. 8, after 9, after 11, 12, 15 and 20. So they have arranged it in ascending order. Once you arrange it in ascending order, just find the middle value by the way we did for previously this method, where we took two sides, two numbers this way, two numbers this way in a ruler format, right? In the ruler format, same thing use. So yeah, in that case the median will be 9. Consider the following array. 1, 2, 2, 2. Okay, so this is all in ascending order. Now, this is a total of 3, 6, 7, 8, 9, 10. So basically, we can't choose one side, because if we choose 5, then there are 4 numbers this way and 5 numbers this way. If we choose 3, 4 numbers this way and 5 numbers that way. So as per the ruler method, it should be 4 if you take, because it's 1, 2 and then 3 and 4, right? But in common sense. But now let's apply the formula. N means the number of items. Now how many items are here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 plus 1. Okay, so now let's apply with the formula. N, what is N? N is the two values that is not letting us get a middle value. Now in this case we had a middle value naturally, right? So but so we were able to take it. But here we can't take it straight away because there's an unbalance. Then we should select the numbers that is creating that unbalance. It is 3 and 5. So you put 3 plus 5 divide by 2. Sorry. Okay. Yeah. So now let's find what the middle value is for this. So what they've said here is they basically took 3 plus 5 divided by 2 is equal to 4 and got the value. But to find which term exactly is, you can use this term formula. N represents the number of items given, which is in this case 10 items are there. So 10 plus 1 divided by 2 is divided by 2 how much? 5.5. 11 divided by 2, 5.5. So so this means the 5.5 item is the middle value. So let's see. 1, 2, this is the second item, this is the third item, this is the fourth item, this is the fifth item. And then a 0.5. A 0.5 between 3 to 5 is actually 4, isn't it? Because we can't say 3.5 because the gap between this is what? 2. So for half of it is now 5 minus 3 is 2. No? So now we are saying 5.5 fifth term. No? So, given that the gap between this is 2, half of it is 1. So, 3 plus 1 is 4, isn't it? That's how you find which item is the middle value. The number of the item, the place of the item is only you found by this formula. But you can't find which number by this actually. You can find only what is the item place. Is it the 5.5th value or 6th value? After that you have to count what is the 6th value up to the 6th value and then get your number. Now but in this case they have basically got the gap between the two and divided by 2 and got 4, which is the same thing around only. But you see, so because the gap is 2 here, half of it only we need. So half of 2 is 1. So 3 plus 1 is 4. Okay. Let's see. Medians of ungrouped frequencies is found in a similar way. Right. So you have your frequency and the cumulative frequency. Right. So now there are how many items? Frequency is the, you must remember, frequency is the number of items in a data set. So number of items plus 1 divided by 2 will give the item number which has the middle value, which is the median. So they are saying 18th item is the median. Now, where should the 18th item be? For that only you will use this cumulative frequency column. Now, how this is created? We know 3 plus 7, 10, 3 plus 7 plus 12, 22, 3 plus 7 plus 12 plus 8, 30, and all of it is 35. So, 18th item must be around here, isn't it? It is in this category. So, this 18th item is 16, isn't it? Now, let me further explain you. Now, this is not grouped. So, how it looks like is, now 8 has come 3 times. So, try it by yourself, okay? 8 3 times, 8, 8, 8. That only they have written as 8 and 3. Now, this is 12 7 times. After that, 12, 1, 2, 3, 4, 5, 6, 7. Okay, see, 7 times. That 7 times they have written as 12 and 7. And 16 has come 12 times. 16, 16, 7, 8, 9, 10, 11, 12. And 17 came 8 times. Let me show you. With this you will totally understand everything. 8 times. 8. Then 19 came 5 times. 1, 2, 3, 4, and 5 times. Now easy like games. Okay. Now when we apply this median formula, we get the number of the item that has the middle value. They are saying 18th item. Now let's count what is the 18th item. Now this is the first item and it's going horizontally because that is the way I wrote it. Okay, so let's see. Or if it comes vertically even. So but however the next numbers must be in this order because that's the way they've given it. Because why? Because we have to first of all arrange our numbers in ascending order. That's the reason. You can't have 19 first. You must have the small figure first and in ascending order. Now it is all in ascending order if we go like this. Okay. So now the 18th item we have to find. This is the first item. Then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. After that 11, 12, 13, 14, 15, 16, 17, 18. This is the 18th item. See? So this is the item that gives us the value 16. Right? That is why they say 18th item has a value of 16. as we can see from the cumulative frequencies in the right hand column of the above table. See this is how you, so this is what they have been meaning. Okay. Okay. Then how to find the median of a grouped frequency? Now, to find it for a grouped frequency, you have to draw an ogive. Ogive, I told, we use straight lines to set it like this. And it is not a downward ogive, it is an upward ogive as a normal one. So basically they'll give you this class and the frequency, and you have to create a cumulative frequency, that is 17 plus 9, 26 and so forth. And then you have to jot the cumulative frequency against the class and the against the classes um, lower limits, right? Because in this case, yeah, it should be the lower limit. It can, yeah. So basically, you are not asked to draw the ANOVA in a computer-based assessment. So you just have to know how to obtain the median from ANOVA. Okay. So from the lower limit only, they have drawn. So these are lower limits, to be honest, right? Right. Oh. Then, okay, for the upper limits. Okay, so the frequencies are as follows. The cumulative frequency here, and they have got the cumulative frequency, and what they have done next is they applied the median formula, which is n plus 1 divided by 2. How many items here? The frequency, total number of items is the total frequency, which is 40. So 40 plus 1 is 41, divided by 2 is how much? Okay, so the total number of items is 40 plus 1 divided by 2. But here they multiply by half, which is kind of weird because it can't be the case because they uh, considered, so the first 0 should be then number of items they consider 0. It can't be it. So the number of items is 40. They have not added the 1, which is why it is not right. Okay, so it should be basically 40 plus 1, 41 divided by 2, 20.5th item. Now, if you as you have drawn the cumulative frequency in the graph, you see you have 0 to you have the number of items here. The 20.5th item must be in this 26 items category because yeah, so it's the 20.5th item is so this shows the number of times the item was there. So it should be in within 26. So because it's 20.5. So but you can't tell anything by looking at where I am pointing the cursor because that is just a data. But once you look at the graph, you could see there's a 20.5. It should be slightly above. 20.5, if you mark it on the graph paper, you can exactly find the mode value. Sorry, the median value. Just like for modes using histograms. For medians, we follow for a grouped frequency distribution, we use organ. So 20% exact value here they've approximated to 380 rupees. So definitely I'm sure in the exam they'll give you the graph paper with cumulative frequency on the side and horizontally the values, and you're supposed to find the median. By finding the median, first find which term will or which item number will give us the median value. Then search that item number in this y-axis, which should be 20.5 in this case, 20.5th item. Then for 25th item, what is the value? You could jot down, go move with me in the cursor, see, and go below. You'll get the answer. Right? So, advantages again is easy, not affected by high or low values, it can be the actual value in the distribution. However, it fails to reflect the full range of values and not suitable for further statistical analysis, and arranging data into order of size can be tedious because making it to ascending order, let's assume you have a large set of data, then it could be really challenging. So if you are asked to find the median of a set of ungrouped data, remember first just a revision. Now this is a revision part where they are saying to first of all arrange it in ascending order. Then count the number of items in the array, select the middle value, whatever. But if you get an even number of items, let's say like number of number of items means the even numbers. The total number of items are even numbers. What are even numbers? Those divisible by 2, which is which is 2, 4, 6, 8, 10, 12. Those are even numbers. I hope you all remember this from school. So the if you get total number of items as an even number, then you should understand, okay, I cannot anyway find the middle value by simply looking at it. I only have to find the middle value by applying the median formula, finding which term, and then detecting it in the ruler format, or else I have the other option, which is I will get the middle value of the two items that are distracting. Like the example we saw at the beginning here, 3 and 5, 3 plus 5 divided by 2, I can get the middle value straight away. You don't have to apply even this. But if you're just for knowledge, in the exam you don't need to do so. Because now see, this is 10 items. 10 items is an even number. So in even numbers, you just add both of the middle values and divide it by 2, right? So you get your middle value. median. Okay, so with that we finish the chapter on discrete data, descriptive statistics. Um, so I hope you all have a clear understanding of what is mean, mode, and median, and also of what is an archive, what is a histogram, and what are frequencies and grouped ones. Have a look again at these with the lecture and work out your revision key questions. We have worked similar questions um, here. So what you have to do, I will suggest for these type of basically the now for these type of mode of a grouped frequency, you can histogram or guide. You could so mode and median is different. So median of a grouped frequency can be found in an OR guide, but mode can be found only in histogram. See, so there's a difference that you need to remember likewise. So midpoint in a discrete data and midpoint in a continuous data. So what you need to do when it's a midpoint in a discrete data, well, it's 25 to 30, so it is basically 25, 26, 27, 28, 29, 30. So by the look of it, um, so but it's just less than 30, it's not equal to 30. Therefore, you can ignore 30. In that case, 27 will be your discrete data's midpoint. But if it's a continuous data, then of course 30 is included because we would be saying that it is up to and including 30. So we will include in a continuous data, we will include both 25 and 30, right? So 25 and 30 if we include, so it will be totally an even number of items, number 6. That means we should take the middle value of these two, which is 27. So this plus 27.5. Yeah, see. 27. 27.5. So this is in a mean scenario. In means only you find the midpoints, not in modes or medians. Remember that one. Mode and median is basically the middle value. That is the average, they say. And mode is the highest number of times a particular value appeared. That value only will be the mode. But midpoints are used for mean questions. So in what happens in the continuous data is that in a mean we include both 25 and 30. Then the average will be definitely 27.5. As we take the number ruler format, or if you take the addition of these two and divide it by 2. But if you for a discrete data, we say that the last number 30 will not continue in the next class. So it will start from 30, it will either start from 30 here or start from 31. Since they started it from 30 and they put here less than 30 without saying less than or equal to 30, then you can say consider only numbers 25 to 29 without taking 30 into consideration because they have only said less than. They didn't say equal to. Right? Because of that only I ignored 30 previously, and then if you ignore 30 then you get only two numbers this side and two numbers this side, making 27 your middle number or midpoint. Okay, that's what you do. So I hope you all are very familiar with everything. Keep practicing questions. We will continue to do revision questions and so forth. So with that we finish chapter 7, and let's meet at the next chapter 7, and let's meet at the next chapter, and let's meet for the next chapter.
Thank you for watching the video. Stay tuned with castudies.lk for more lectures online.